Dear students, greetings to all. Today we are going to discuss Unit 5 VLSI design, okay, in that CMOS testing, okay. So in the last class we have discussed um, architectures of CPLD, FPGAs, okay, and their functionalities and number of blocks, different blocks, okay, and their functionalities, okay. So today we are going to discuss CMOS testing, right. So basically what do you mean by testing? What do you mean by testing here? See, what is the use of testing? Okay, testing is used to check whether the chip behaves properly after the fabrication sequence is completed. Okay, so I can say that uh, testing is used to check whether the die or we can generally call chip behaves properly after the fabrication process is completed. Fabrication, I can say, sequence is completed. Okay, so basically the testing used, see, when we are going to test, suppose I designed a circuit, for example, okay, using gates, whatever, right? So when after fabrication, after manufacturing is completed, okay, then it we need to check whether the given design is properly functioning or not. We need to check that functionality. Okay, we need to verify the functionality, right? So whether it is whenever it's given input, then automatically we need to get the proper output, okay, which we designed, right? So I can say, in other words, if I say testing is nothing but I can say a verification of what, or functionality, right? Verification of functionality by what? By giving the inputs, by verifying the outputs, right? So testing is nothing but a verification of functionality by giving the inputs and verifying their outputs, okay. So after, see, there is so many reasons actually, okay. So while manufacturing, okay, what will happen, there is so many process are there, as you know, okay. In the first unit you studied, okay, CMOS fabrication, right? So while fabrication, etching process will be there. So there is a mismatch of connections, a possibility is there, okay. So many factors are there, okay. That's why after design, after manufacture or fabrication, there will be a testing, okay. That testing generally called CMOS testing. We have so many methods in this, okay. Like vector testing, like stuck at 0, stuck at 1, okay. Like that we will see further, right? See, in this I can say simply, if once a logic function has been designed, it must be tested, right? And the fault chip should be identified from the good chips. Simple, okay. See, I designed a logic function, okay. So see, that function is verified through the by giving the inputs and checking the outputs, right? So how can identify these faults after fabrication? Okay, by using these test methodologies, okay, I can identify fault chips, okay, from the good chips. Okay, so let us see. uh, Generally, so which means what I can say, I will write here, VLSI testing deals with techniques that are if a die, generally it is called a chip, behaves properly after, I can say, the fabrication sequence is completed. Okay, so see, generally what will happen after this step, if my design is tested properly, okay, then what will happen, whatever the die passes these all test phases, then they are packed and sold out. Okay, so generally companies do like this. Okay, so if I mention that, if a die, or I can say rewrite it, a chip uh, passes the testing phase, means all methodologies, okay, then it is packaged and sold. Okay, so after passing all test tests, okay, the chip will be packaged and sold. So basically, see these type of faults, whatever the faults, suppose in my for example I'm giving here, suppose I have an end gate here. Okay, so A B, right, y is output, for example. Okay, if I given 0 0, then there is a chance of misconnections due to this one, and this will be passed after. Okay, passed after strucket 1, like this strucket 0 it is called. Okay, instead of 0 input, and I am getting here 1 as a input, so therefore the output will be changes. So by giving the inputs as my input, but output is varies. Okay, so generally these faults we need to understood as a manufacturing defect. Okay, so we designed properly only. Okay, the particular circuit I designed proper only, but while manufacturing, that all etching process of vias or mismatch of connections, due to these all, the output will be changes. Okay, so I can say this, okay, we can comment. So fault may be understood to be a manufacturing defect. Okay, so in this case, we are understanding that there is a manufacturing defect. Okay, so by, see, there are both chances. Actually after design, okay, generally after design we will check this design verification. Okay, functionality we will check, input output functionality. If it is correct, then only it's sent to the manufacturing. Okay, so after completion of manufacturing fabrication, then output input is varies, differs, then automatically this is a defect of manufacturing. General understanding will be defect of manufacturing. So after manufacturing it is a defect, then this will be almost this will be damaged one. Okay, so we need to design another one, and we need to send to the manufacturer. Okay, right. So what is the need for testing actually? So same thing we discussed here only. Just now we discussed need for testing. Okay, so see why we are going for testing, because our manufacturing process is very complex. Okay, so maybe after that completion of the process we need to check whether our functionality will be verified. Okay, so it is properly working or not. Okay, so simply I can say that uh, due to the complexity, I can say, of manufacturing process, not all chips on a wafer correctly operate. Okay, so so after manufacturing, so it is not necessary that whatever the functionality, all chips are functional properly or operate. Okay, so there is a chances of small imperfections. I can say there is a chances of small imperfections in starting material processing steps. So, as you discussed in the unit one, okay, while manufacturing, okay, there is a chance of getting the material imperfection steps. Okay, whatever the material you are adding, suppose I'm adding metal. Okay, if there is a defect in uh, bad vias, then automatically the connections will be differs. Then we need to that is the reason after fabrication, after manufacturing, we need to go for test. Then only we need to approve. That is uh, faultless or fault one. Okay. So need for testability testing is what? So due to the complexity of manufacturing process, okay, so it is not necessary that all chips are functioning properly or correctly. Okay, for that purpose we need to go for test. Okay, testing. So testing is common for every design before going to fabrication. Okay, you need to remember this. Okay, all right. In fabrication process, okay, we have a photolithography, photo masking, and photolithography. In that we have a photo masking and etching process will be there. Okay, so in that maybe result in bridge connections or mismatch features. Okay, or connections. So there we have a chances of getting faults. Okay, so I can simply say that uh, for example in photo masking, maybe may result in bridge connections, for example. So bridge connections, yes, there is chances, right? uh, or missing features. Okay, so there is so many possibilities. Okay, uh, uh, after fabrication, may we get a fault, right, in connections or fault in output. Okay, so the main, now you got the main aim of testing procedure to determine, okay, chips are good, okay, to use in the end system design basically. Okay, so right, it is I can say of the test procedure aim of the test procedure to determine which chips or dice, you can say, are good and be used in the end system design. Okay, end system, you can say. Okay, this fault of a design may occur in fabrication process, okay, in various levels actually. Okay, so let us see testing of a sorry chip can occur in various levels. Okay, let us see the first one. If I say at the wafer level, okay, any chances of occur in wafer level, and at the while packaging, you can say packaged chip level, you can say chance of occurring, and next is at the board level while fabrication at the board level, and I can say at the chip design level, okay, chip level, and I can say while the field connections, while connecting the fields, there is also we have fastability. Okay, so testing of a chip can occur. Okay, so in various levels: wafer level, package, board level, chip level, and at the field also. Okay, so the defecting of a fault in manufacturing chips at the earliest stage, then the manufacturing cost is we can reduce or it may be low. Okay, so what we need to do is these defects at the levels of these defects we need to find earlier, then the manufacturing cost will be less. Okay, so in earlier stage, if we find the faults, then we can stop further procedure and we can recorrect, or I mean recorrect in the sense we can go with new fabrication, new design and new fabrication. Uh, then we can proceed all fabrication process to complete the manufacturing. Okay, now we'll see types of tests. Okay, so what type of test we have in CMOS testing. Okay, so there are two types of tests mostly used. There are, okay, two types of tests. Okay, so the first one is functionality test. Functionality testing, and the second one is sorry. Testing or test, you can say manufacturing tests. Okay, testing. Okay, so there are two types of testings. Okay, one is functionality testing, another one is manufacturing testing. So let us see the first one, functionality testing. The first one, functionality testing. Okay, so what is the functionality testing? See, the functionality tests verifies that the chip performs its intended function. Okay, suppose you designed a using logic circuits, you designed one particular circuit, right? So you need to check whether input and output functionality, okay, intended what you designed same as it is. Okay, so basically these type functionality tests will be performed in a like a high level languages in software. Okay, uh, like VHDL, Verilog. Okay, through code. Okay, we will check this functionality. Okay, so see here, I will make a point here. The functionality tests verify that the chip or die performs its intended function. Okay, uh, see, example, if I consider example, any function using logic gates or mm, uh, see, whatever functionalities you can take, mux or in microprocessor, most of the functions. Okay, we are giving our logic, okay, and testing the functionality, input output functionality, whether the it performs intended function or not. Okay, so most of the systems, the functionality test involves providing that the circuit is functional equivalent to some specification. Okay, so functionality is nothing but some specification, I can say. Okay, the specification must be verbal description or plain text, like high level language like Verilog or HDL. Okay, so this is nothing but a functional testing. Okay, so functional testing is nothing but simply, okay, it involves providing circuit functionality equivalent to some specification. Okay, so I can say circuit circuit functionality is equivalent to some specification. Okay, some specification. Okay, the specification might be verbal description. Okay, this specification must be, I can say, it is verbal description, or I can say a plain language, plain text, plain language. Uh, I can say plain language. Okay, uh, or I can say this description will be uh, like VHDL or Verilog HDL. Okay, so which are done in software basically. Okay, so this is nothing but a functional verification. Okay, got my point? So simply with softwares we will do the functional verification basically. okay, by using these languages, right? High level languages. In previously we are using Pascal, all this. Now VHDL and Verilog HDL, right? Next we will see the manufacturing tests. Testing. So what is the manufacturing testing? We'll see. See here, in the manufacturing testing, these tests verifies that the every gates or resistors or different components in the chip functionality is correct or not. Okay, so basically after fabrication this test will be done. After manufacture this test will be done. Okay, so simply I can say, if I make a note here, these tests verify that the every components, or I can say gates and or resistors and all different type of components in the chip or die functions correctly. Okay, all right. So basically, see what happened. Manufacturing, in the first unit we studied CMOS fabrication. Okay, in the fabrication what will happen if you design our sample fabrication? Okay, so this is my design, like for example any my circuit, okay, on the chip, right, internally designed. Then what will happen, due to the etching process or due to the doping or mismatch of interconnections, okay, so extra materials will be found, and this makes short of the circuits or disconnection of the circuits. Okay, so these type of testings will be done in manufacturing test. Okay, so these type of faults will find in manufacturing test actually. Okay, so the functionality test verifies the function of a chip, where manufacturing tests used to verify every gate operations as expected, gate operations or whatever. Okay, so the manufacturing defects occurs during the chip fabrication. Okay, the manufacturing defects occur during the chip fabrication. Okay, so the manufacturing defects occurs during the chip fabrication. Okay, so let us see commonly observed defects and the results. What will happen actually in the fabrication? Okay, so commonly observed generally defects and the results. What will happen? Okay, so see here. If I consider this as a defects and taken as results, for example. Okay, so the first one, if I consider uh, layer to layer, that is what I can say metal to metal. metal. What will happen? The nodes are shorted or grounded in this case. Okay, whenever connected metal to metal, then what will happen? The nodes are either uh, sorry, shorted to ground or power supply. That is, you can say VDD. Okay, simply. Okay. The second one. So the second one, disconnections. I can say mismatches and disconnection of wires. In this case, so what will happen here? Basically, disconnections means the open circuit are whether they are connected each other or open circuit. Okay, so it becomes a open or shorted each other. Okay, and third one, thin oxide process. Okay, or substrate or well, uh, thin oxide thin oxide shorts to substrate, or I can say well. What will happen now? This process in the fabrication, the first unity fabrication, all these steps are there. Okay, so what will happen? Input will be floats. Input will be float. Input floating will happen, or output is disconnected. I can say connected. If we observe, okay. So these are the manufacturing testing. Okay, so whenever we have such type of defects, okay, so we will go through the manufacturing testing and we'll find all such defects, and we'll redesign or remanufacture the whatever the circuitry we required. Okay, right. Let us see uh, fault models. Okay, so next our topic is wait a minute, ah, fault models. So let us see the what are the types of fault models. In this, first one is stuck at fault models, and the second one is short and open faults, and the third one bridging faults. Okay, so generally fault models are categorized three types: stuck at fault models, and short or open faults, and bridging faults. Okay, so let us see the first one, stuck at fault models. Stuck at fault models, right. So see, in these stuck at fault models we have stuck at 0 and stuck at 1. So let us see that. So in this we have the first one, stuck at 0 and stuck at 1. Okay, so what is this? Let us see. So basically stuck at let us see the first one. Stuck at 1 means, see, output at any given point will stay 1, for example, then no matter what is the your input connection is. Okay, so let us write this. Let us define output at given point will stay 1, will stay always 1, no matter what is the circuit connection. Okay, so for example, uh, stuck at 1 minute. Suppose I have, I will give the examples, no problem. Further also, we'll solve few example problems. This is A, B, this is Y, for example, right? So I have one at one point, this point I can say P, and it is stuck at 1. So what it is, whatever the value of A, either 0 or 1, sorry, 0 or 1, it will be, this input will be always 1 only, no matter how connection is. Okay, no matter how it will be, input will be connected. Okay, but the p value in this point is 1 only. Okay, so that is called, this is a fault, right, in fabrication, whatever. Next is stuck at 0. Same. So what is stuck at 0? Output at given point will stay always 0, no matter what is the circuit connection. Okay, so same, this also, for example, if I again and get input A, B, then this point if I consider as a P, and this is stuck at 0 in this case. So whatever the value of 0 or 1, but it will consider input, one input always 0 only. This is called stuck at 0, stuck at 0, right? Let us see one example to understand better. Okay. Okay, example 1, right? So I would like to take one and gate. The inputs are A and B, and this is connected with one OR gate, and another input I'm giving it here C. Then C, this is Y, my output. Suppose question is question is uh, if the P is stuck at 1, then the output will be dash, for example. Okay, so see in this case, see this is point P is given, this is point P. Okay, this is what here stuck at 1, right? So this is always 1 here. So whatever the these two inputs, okay, connected to AND gate, and whatever the output of AND gate, but this is default, this fault is there. Okay, stuck at 1, it is always 1 only. This input of OR gate is always 1. Okay, so let us see the what is the output. Okay, so as per definition of, if I see as per definition of OR gate, what is the as per definition? If any input is logic 1, then what will happen? Then output will be logic 1 only. Is it right? Okay, let us see. Let us see this one. See, this is stuck at 1 at this point P, right? Now, if I want to give 0 or 1 at the C, forget about this, okay? So it is definitely this output of AND gate not depends on the A and B values because it is stuck at 1, right? Now, if I have C value either 0 or 1, okay? So what is the kind of OR gate definition? If any input logic high, then the output will be high on all the time, right? So see, one of the input is high all the time, okay, because it is stuck at 1. So either 0 or 1, definitely the output is high, okay. So the output is 1. Got my point? So this is the manufacturing defect, okay. So output is this is called stuck at 1. This is one of the faults, okay, stuck at faults. As for example, in the same for the same one, if I'd like to take, okay, suppose this is stuck at 0, for example, this is next one stuck at 0, okay, this point will be, I'm taking next time stuck at 0, so this point will be 0 here, right? Then see, then okay, so output will be, suppose this is C, this is C my value, okay. So whenever you have 0, the output will be C, second one, okay. So output either, if it is 0, then output will be 0, it is 1, then output will be 1, okay. Got my point, right? Yes. Next example, another, we'll see another example too, right? See, clearly I will explain, I will give two points, uh, 2 points I will give better. Any terminal may stuck at logic 0, or I can say logic 1, logic 0 or logic 1 is referred as stuck at fault, okay. So any terminal may be may stuck at logic 0 or logic 1 is referred as stuck at faults, okay. So if I want to say another way, at the terminal, okay, no need of this, I want to say generally, at that particular terminal, whatever the stuck at terminal, okay, the input output value is never dependent, remember, okay. So there is no dependency on input and output at the stuck at values, okay. Okay, right, let us see the example, another simple examples to understand better, okay. I would like to take another NAND gate, sorry, AND gate, and values A, B, okay, and this is Y my output, okay. So in this case, say the first value stuck at logic 1, okay. So what is the truth table of AND gate? Just see here, just see here, if I consider this as my truth table, A, B, okay. So I would like to take correct value of Y and actual value of Y, okay, the output. Let us take, this is stuck at 1, for example. So at this point, okay, this is stuck at 1, for example, okay. So see, AND gate, what are the inputs we have? 0 0 1 1 0 1 0 1. Okay, so general output, what is that? 0 0 0 1 for AND gate, right? So actual output for this circuit, see, it is stuck at 1. Whatever the value of A and B you are giving, I mean, sorry, A value 0 or 1 you are giving, but this one is 1 only, because it is stuck at 1, fixed value. Okay, no matter whatever the input connection or output connection, okay, fixed value is 1, right, at this point. So see, all the time in this case 1 only, right? A is all the time here, in this case 1 only, right? So see here, then what is the output? 1 0 1 0 0 1 1 1 1 0 0 1 1 1. This is actual output in this case. Okay, this is the actual output of Y in this case. Got my point? This is called stuck at logic 1. For the same circuit, if I take stuck at 0 for the same circuit, uh, okay, again I would like to redraw for the same circuit. So if we take stuck at 0, logic 0, then AND gate AB, okay, and Y. Now if I again redraw the truth table to understand better, AB and correct Y and actual Y. Okay, so wait a minute, right? So this one will be 0 0 1 1 0 1 0 1. Okay, so generally actual output is indicate. Okay, now this is here in this case again I am saying here stuck at 0, logic 0. So what are the value of A, either 0 or 1, doesn't matter. Okay, all the time this input of an AND gate will be 0. Okay, this is all the way 0, right? So see, in this case, A all the time 0 only. Okay, even though we have I given 1, but it won't take 1 because it's struck as a 0. So it considers 0 only. Then what is the output? 0 0 means 0. 0 1 means 0 only. 0 0 0 0 1 0. All zeros. Actual output is this one. See. So this is the difference when we have the faults in our circuit design while manufacturing. Okay, so we need to test all this. Okay, so this is one of the stuck at 0 and stuck at 1. I think you hope you all understand this one, right? So another basic example I would like to take. Uh, then we close this concept. If I have circuit and gate, this is AB. This and NAND gate. For example, this is C. Now these three are connected to the NAND gate. Y is equal to, sorry, we'll check the output. What is the output, right? Question is, if I take the question in this case, if point P is stuck at 0, then the output will be dash. Okay, so where I can take here P, Anyway, okay, this is given stuck at 0 in this case. Okay, so here for whatever the values of A and B, okay, the output of AND gate will be always 0 because it's stuck at 0, right? So in this case, whether it is 0 or 1, C is either 0 or 1. As per NAND gate, what is the definition? Okay, for NAND gate, what's the definition of now? If any input is logic 0, then output will be high, that is 1, logic 1, right? So in this case, see here, in this case, input is 0, any input, any one of the input, this is 0 anyway because it is stuck at 0. So what, no matter whatever next inputs, either this is 0 or 1, 0 or 1, any input is 0, output is high. So this is high. Got my point? So this is stuck at 0 or stuck at false in a testing, right? These are the general faults. Got my point? Like that, you can, if I have, see, another point I would like to say, it is not necessary that we have only stuck at fault only one in a circuit. No, it is a single stuck line will be there. SSL we can call single stuck line, okay, or multiple stuck lines, okay. So which means what? I have a one circuit, okay. For example, this one. In this case, A, B, C. So here I have stuck at 0 and here I have stuck at 1, for example, okay. So this is, it is also possible, okay. This is called multiple stuck line, okay. So it is called multiple stuck line fault, LIN, stuck line fault, okay. So previous all examples I shown with single stuck line faults, okay. On my point, so maybe a fault, these faults will be more than one or one, okay, whatever, right? So next we will see second one, short and open faults. Second one, short and open faults, okay. Let us see this. So this is also called, we can call simply, first of all, first one is stuck open fault, okay. When it is opens floating node, then it is called stuck open fault. Let us see this one, right? So for example, I have a design circuit of CMOS logic, CMOS design, okay. Pull up will be transistors, PMOS transistors, this is A and B. Pull down will be NMOS transistors, and, as we know, this is ground, okay. This is VD supply, right? So here is my output Y, for example, right? So so in this case, this is basic circuit, but I want to show fault in this circuit. So this one will be, I'm taking as this is floating here, and here is floating, okay. This is empty circuit, I mean this is open now. this circuit is not here. Okay, so I want to erase this one better. So okay, so it is not here, for example. Okay, so this circuit is like this only up to here. Okay, and up to here like this only, right? This is I mean this is open circuit here, this case. Okay, so whatever the enter mark I kept, this is open circuit. Generally this is called floating. Okay, so write with other name. So this is called floating node. Floating node is here is the open circuit. Okay, then we'll see fault free circuit. So y is equal to what? A plus b. If it is not fault, both are not, I mean in this case it is not open circuit, then this is fault free circuit. Now if we take in fault circuit, so what is that? Y fault I'm saying here f. This is a plus b plus ab bar z. In this case I taken z as previous value. Okay, this value means previous value. Okay, so in this case we have test patterns and cases. We have for case 1 what will happen, like that. Okay, so if I consider case 1, then both a b is equal to 1, then this is, sorry, it is y, z, y, this is y, it is y, sorry. Okay, so y will be pulled down to 0. If consider case 2, a is equal to 0, then b is equal to 1, then what will happen? Y is retains its value. Retains the value. Okay, so simple is whenever you have stuck open, this is floating here in this case. Okay, this is open circuit. Okay, then the output will be changes. Okay, so this is called stuck open. Okay, so whenever is certain points will shorted, then it is called stuck short faults. Okay, so this is the short open faults, right? On the point. So we have further in MTech level. Okay, so we have test patterns also. The patterns like we have for this open faults. Generally, we have AB is equal to 0 0 and AB is equal to 1 0. Like patterns will be there. Okay, depends on the cases. Okay, no need of here discussing all these things, right? So simply you need to know for any circuit. Okay, if two nodes are floating, then this is called floating node. Okay, and fault free circuit output will be like this, fault circuit output will be like this. Okay, right. Next is the last one, bridging faults. We can see bridging faults. Okay, so bridging faults is nothing but I can say these will be pair of nodes will be considered in this case. Like I will write 1 2 points here. uh, Models short circuit. Generally, short circuits, or I can say pairs of nodes considered. Okay, pairs of nodes will be considered. Mode of this short. Okay, I will show what is that actually. So, uh, see here, for example, if I consider indicate A, B, okay, are two inputs, then this is called bridge. It is a fault. Okay, so this is called, say, bridge. Okay, so this is one of the fault in while manufacturing. Okay, so due to the defects, they both are connected. So it made a form of bridge. Okay, for example, if I take truth table for this one, A, B, if Z is my output, then Z fault will see, which is this means correct Z, and the actual, this one is a actual Z. Sorry, what happened? Right. So anyway, as we remember, this is 0 0 1 1 0 1 0 1, right? So indicate actual output is, as we know, 0 0 0 1. Okay. Right. Now see here. In this case, what is the output? Both are zeros. A is 0, A is 0, B is 0. Both are connected. Here is 0 0. Output will be 0 0 0 0. Right. Next is B equal to 1, A equal to 0 again. So this is 0, this is 1. Now this is 1, this is 0. Now what is the output? We don't know. Here is the fault. We are unable to find the output. Like that, this is in this case 1, in this case 0, then unable to find the output. Last one, both are 1. So this is 1, this is 1. So I know the output because these are connected, both are 1. Okay. So this is the truth table of uh, default, I mean bridging. Okay, bridging faults. Okay, this is a bridging fault which I got and get out. Got my point? So this is the bridging faults. Okay, so right. So these are the fault models. We have three fault models. One is stuckate fault models, and another is short and open faults, and third one is bridging faults. Okay. So these are the defects while manufacturing. Okay, we need to overcome these faults. We need to go for testing. Okay, right.